Hello everyone. Today in Geometry Standards, for our very first day of Semester 2 lesson, we are going to talk about 5.7, which is the Pythagorean Theorem. Okay? And right here it does say proof. Okay? So we are going to show you the proof of the Pythagorean Theorem and why it works in a few different ways, because it's geometry. You need to know why it works. Okay, so talk through this. There's an additional video. It says optional. That is a great video to watch in case this makes no sense to you. Okay, but go ahead and continue. I promise it won't be too long. Okay, so the first thing we're going to talk about is the Pythagorean Theorem. Okay, and remember, a Pythagorean Theorem is when we have a right triangle. We know it's right because it has like one of those little squares in the corner, or it tells us it's a right triangle, or it has 90 degrees in the corner. Okay? The Pythagorean theorem states that on a right triangle with A and B as legs, okay, so that just means that one side length is going to be an A length and the other side length is going to be a B side length. Okay, that could be 4 inches and 5 inches. That could be 200 inches and 300 inches. Okay, it doesn't matter. They are just going to be different numbers. Okay, C as the hypotenuse. Okay, so a good time to review here. The hypotenuse is when we find our right angle and we look to see where it's pointing. Okay, so I see the box, the point is pointing over here, so this side length is my hypotenuse. Sorry about that. Okay, and then these will be my legs. It does not matter which leg is which. Okay, and this leads us to our Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, you have worked with this many times before. Okay, so in the first proof we're going to talk about, we're going to show or prove that a squared plus b squared equals c squared. And the really cool thing here is that there's a picture. Okay, so I hope you see a bunch of right triangles. The cool thing about this is all of these right triangles are exactly the same. So this first one has a side length of a and b. The hypotenuse is c. Okay, A and B with a hypotenuse of C, A and B with a hypotenuse of C, and again, A and B with a hypotenuse of C. You can see that these 4 right triangles are forming a shape of a square because all of the sides are the same, and they're length C. So the area of the entire square, okay, well, when it's asking us about the entire square, okay, we can see this side length is A and B. And if I want to combine them, I'm going to add. So that's where that plus came from. I'm just adding those. Okay. Well, then if I look at the other side, let's do this one in red. Well, this one also has an A and a B. And since we want to combine them, that's going to be A plus B. And we're going to throw those in parentheses so that we don't get them confused. Okay. And then we get to do some algebra. Okay. This is tricky algebra because it only has letters. If I multiply, okay, if I have 2 binomials and I want to multiply, I need to do the whoop whoop. Okay, that's what many of you call it. This is also called distribution, or you can draw this in a box. Okay, so A times A, that's going to give me A squared. A times B is going to give me B squared, A times B does not give me B squared. It gives me AB. And then I'm going to move to my second term. B times A is the same thing as AB, so I'm just going to write it that way. And then B times B is B squared. Okay, and I'm adding all of those because they were all positive. So if I combine my like terms, right here I have AB, so I'm going to do a squared plus 2ab plus b squared. Okay, and the area of one of the triangles, okay, so I'm looking at one triangle, so if I use this dark blue one down here, let's use a different color. Now we know to find the triangle, the area of a right triangle, we do 1/2 base, well in this case my base is b, times the height, and in this case my height is a. So 1/2 b times a. So using those two different parts, okay, we're going to continue. The total of all of those four triangles, okay, so we're taking one triangle and we're going to multiply it by 4. Okay. And to make it a little bit easier, since it already has divided by 2, I'm going to leave out this 1/2. So it's base times height, which is b times a. Okay. If I multiply those, I have 4 over 2. That gets rid of this 2, and this becomes a 2. So it's 2ba or 2ab if we want to keep the order nice. Okay. Then we're going to talk about the area of the middle square. Okay, so let's switch it up. We're looking at this middle square. Okay, so this yellow square has all of the side lengths c. Okay. And if I want to find the area of a square, we did this, it was base times height. Well, the base of it is c, and the height of it is c. Well, if I have c times c, that's the same thing as c to the second power, or c squared. Okay. Now, how can we find the area of the middle square only in terms of a and b? This might get a little tricky. The area of the entire square, okay, well, the area of the entire square was a squared plus 2ab plus b squared, okay, and I got that from this first part, minus, okay, so minus the area of 4 triangles. That's where we got this. So minus 2ab is going to equal the area of the middle square. Well, the area of the middle square we said was c squared. Okay, so if we combine like terms, I see that I have positive 2ab and negative 2ab, so I'm going to be left with a squared plus b squared equals c squared. Okay. Now, why were we able to take this formula? Okay. Did it just, I understand all the pieces, but why did we come up with this formula, the area of the entire square? Okay. So if I want to look at the area of the entire square, okay, this whole thing, okay, and I'm going to subtract the 4 triangles, okay? So if I have this whole thing, let's shade it in real quick, and I take out my triangles, okay, I'm only left with that yellow triangle in the, or that yellow square in the middle, which was c squared. Okay? And that's why we have this Pythagorean proof. Now, similar to class, how I would tell you there's not one way to do a proof. You could do it multiple ways. The same thing is true with the Pythagorean Theorem proof. Okay? So tomorrow we're going to talk about a whole nother proof. Don't worry, there's plenty of more if you want to go look some up. There's also a video if you would like someone else to explain. It's kind of cool because you get to see the shapes move around a little bit differently. Okay? So tomorrow we're going to go through this before we jump back into Pythagorean Theorem and we learn it in a slightly different way. Have a great day.